In this video, we'll look at how you can solve cosine theta equals square root of 2 over 2. And so a good tip is to think about which angles have a cosine of square root 2 over 2. It's a lot like finding exact values, but just in reverse. So you'll find there are a lot of similarities here. Okay, so let's take a look at our outline. In the first step, we'll analyze. So there are two key things here. First, we want to decide which quadrants our angle answers should be in, and then we'll find our reference triangle. And that reference angle will help us determine our angle answers, which is what we do in step 2. So let's do that for cosine theta equals square root 2 over 2. All right, our analysis, the quadrants, we find out which quadrants our angle answer should be in using the acronym ASTC. Think all students take classes. And you label your quadrants, starting your way in quadrant 1 and working your way around. So label ASTC. And this helps you recall which trig functions are positive in each quadrant. So they're all positive in 1, only sine and cosecant in 2, tangent and its reciprocal cotangent are positive in 3, and cosine and secant are positive in 4. So looking at our equation again, we are looking for cosine of theta equal to a positive value, positive square root 2 over 2. So that means we know our angle answers should be in quadrant 1, where they're all positive, and then that C tells us cosine is positive in quadrant 4. So let's sketch in our angles here. All right, now we're ready to determine our reference triangle. And anytime I see a value root 2 over 2, I feel very, very happy because I know that deals with that isosceles special right triangle, that 45, 45, 90. So eventually you'll be so familiar with your special right triangles, that value will just pop out to you. Okay, if you need any help with that, I'll post a link to a playlist that has videos on the properties of special right triangles and how they work with the unit circle. But for now, let's just assume we have that knowledge and we're working here with the special right triangle where both the horizontal leg, remember cosine is the x-coordinate, so our horizontal leg is root 2 over 2. And if we were finding the sine of theta, we'd be looking at the vertical leg or the y-coordinate. Okay, but again, we're dealing with the 45, 45, 90 special right triangle here. And often when we're solving a trig equation, we actually want to be in radians. So let's rewrite 45 degrees as pi over 4. And now we know that's our reference angle. That will help us find our answer in quadrant 1 and quadrant 4. So I showed that right there. Remember, our reference angle is simply the amount of rotation from a terminal side of an angle to the x-axis. So now that we've done our analysis, we're ready to state our angle answers. Now let's work on the angle in quadrant 1. That one's very simple because an angle in quadrant 1 is its own reference angle, so that angle must be pi over 4. All right, and then we want to find our quadrant 4 angle. So we rotate almost all the way around. We get to that quadrant 4 angle, so we're just a little bit short of 2 pi. And you may want to write 2 pi as 8 pi over 4 if you like working with common denominators. And so you can see that we are 1 pi over 4 short of rotating all the way to 8 pi over 4 or 2 pi. So to find that angle, simply subtract 8 pi over 4 minus 1 pi over 4. And that angle in quadrant 4 is 7 pi over 4. Eventually, you will be so familiar with your unit circle, with solving basic trig equations, you'll just know that these two are the angles that have the reference angle of pi over 4 if you're looking in quadrant 1 and quadrant 4. So these are our answers on 0 to 2 pi, or on the unit circle. And before we finish, let's also take a minute to write our solutions if we were finding the solution to the equation for all solutions. Okay, so to do this, we write two little equations, and we create them using our answers that we stated above in blue. And so we'll say theta can be pi over 4, but it can also be all the angles that are coterminal to pi over 4. Those would all substitute back in and be true solutions in the equation. And so we write that saying plus 2 pi, which is a full rotation around the unit circle, k. And k is an integer, and depending on which integer you plug in, you get a different coterminal value. So that's one of our solution equations. And the other one will be very similar. This time we just use 7 pi over 4 plus 2 pi k. All right, so it's nice to practice both ways, see how you may be asked to find solutions for trig equations. I'll post a lot more worked examples, so be sure to check out the links in the video description. Good luck with your trig solving, and thanks for watching.